Hello, welcome everyone to another Sound Talk Show. Today we are going to code Wolfram language. Wolfram language, fantastic. Let's get started. Okay, so Wolfram language, we're gonna code Wolfram language and doing the Advent of Code 2023, day 9. Okay, let's begin. We did day 1 to day 8. So today is day 9. Live. I haven't read the problem yet. Okay, let's begin. So let's move this here so you can see. Can you see it? Yes. Okay, so it needs to move more. Okay, day 9. You ride the camel through the sandstorm and stop where the ghost maps told you to stop. The sandstorm subsequently subsides, somehow seeing you standing at an oasis. The camel goes to get water and you stretch your neck. As you look up, you discover that you must be yet another giant floating island. What must be another yet giant floating island? This one made of metal. That must be where the parts to fix the sand machines come from. There's even a hang glider partially buried in the sand here. Once the sun rises and heats up the sand, you might be able to see the glider and the hot air to get all the way up to the metal island. While you wait for the sun to rise, you admire the oasis hidden here in the middle of desert island. It must have a delicate ecosystem. You might as well take some ecological readings while you wait. Maybe you can report any environmental instabilities you find to someone so the oasis can be around for the next sandstorm warn traveler. Okay, you pull out your handy oasis and sand instability sensor and analyze your surroundings. The oasis produces a report of many values and how they are changing over time. Your personal input. Okay, each line in the report contains the history of a single value. Okay, each line in the report contains the history of a single value. All the above is prelude. That doesn't make sense. But here is the input. So you got several lines. Each line is the input history of a value. Okay, a bunch of numbers. To best protect the oasis, your environmental report should include a prediction of the next value. Okay, that's basically what you have to do in each history. To do this, start by making a new sequence from the difference at each step of your history. If that sequence is not or 0, repeat this process. Okay, make a difference between the lines or between numbers. Start making a new sequence from the difference at each step between the lines, I suppose. I'm not sure. Yeah, between the lines. So if that sequence is not or 0, repeat this process using the sequence you just generated as the input sequence. Okay. Once all of the values in your latest sequence are zeros, you can extrapolate what the next value of the original history should be. Okay, so we got this input. Let's start to work on it. Let's get the input. So the input is, so paste the input. Here's today's talk show. And let's begin. Let's start a Wolfram language. Paste it. Okay, so that's the input, kind of. So here's the Wolfram language, Mathematica. And if you don't know Wolfram language, you go to just search for Wolfram language in depth, and you can get the download on the official wolfram.com website. You can download the Wolfram engine for free. And you can read my tutorial, a guide about what's a Wolfram engine, what's Mathematica, Wolfram language, Wolfram script, what's the difference. Or you can buy a Raspberry Pi and it comes with Wolfram language. It comes with Mathematica, I believe. Okay, so that's about Wolfram language. So let's start coding. So here's the input. You make the difference between the lines. So for example, here, okay, you make a difference, and you got the same number of numbers. And if that's not all 0, then you make a difference again, but with respect to which line, I don't know. So let's see. In the above data set, the first history is 0, 3 something. Because the value increases by 3 in each step, the first sequence of differences that you generate will be, oh, okay. So it's not between lines, it's a difference between the numbers. Okay. So the difference value is sequence is 33333. Note that this sequence has one fewer value than the input sequence, right? Okay. Since these values aren't all 0, repeat the process. Okay, do it again. The values differ by 0 at each step, so the next sequence is 0, 0, 0, 0. This means you have enough information to extrapolate the history. Visually, this sequence can be arranged like this. Okay, yeah. Okay, this is called difference sequence. Wait, there's a mathematical term for this. I forgot what it is. But anyway, so to extrapolate, start by adding a new 0 to end of your list of zeros, okay? Because the zeros represents differences between the two values above them. What? So you add a 0 to your all zeros, then you also add a variable to the end of the previous difference lines. Then you can start filling in placeholders from the bottom up. A needs to be the result of increasing 3. Okay. So difference, do they count? What does the order count? Are they the difference of absolute values or not? We don't know yet, but so far the sequence is increasing. So you take the second number minus the previous number, okay? Then you get a positive number if the second number is larger, right? So you can start filling in the placeholders from the bottom up. A needs to be the result of increasing 3. Okay, A is 6. Wait, what? Wait, A is 3. The value to its left by 0. The value below means A must be 3. Oh yeah, that makes sense. Because the difference between A and 3 should be 0. So, and then you need to find out B. B is 15 plus 3, 18. Okay? You know, you can kind of feel what is the problem asking without reading the details. Okay, so the next value of the first history is 18. Okay? You find the difference sequence and you then until it's all 0, then I don't quite get it. So far you don't need all the differences before. You just need the difference of last two numbers. Okay, you need all the differences before because you need to get it to 0. Okay, it seems to be. So find all 0 differences for the second history required an additional sequence. Okay, we go on to the next line. So 1, 3, 6, 10, 15, 21. So the input 1, 3, 6, 10, 15, 21. That's correct. Okay. Then here is the result you get. So you need to first of all do this until your order numbers is 0. Then you go one step up. So 1 plus 0 is 1. 6 plus 1 is 7. And 21 plus 7 is 28. So 28 is the answer. So you basically, you do this sequence difference, different sequences until you get all 0. Then you start with the line before it. You take the last number, then you add that number to the line before it. Then you get a new number. Then you add that number to the line before it. Okay, so you just add so you do these different sequences until you get a line that's all 0. Then you just drop the last line. You go to the previous line, take the last number, you add that last number to the previous line, and repeat. That's right. So that's how you get 28. Okay, so the next value, so let's see the next one. So this one, so you see 0, 0, 0, so you get 2. Last item, 2 plus 6 is 8, 8 plus 15 is 23, 23 plus 45 is 68. That's correct. Okay, so you got a bunch of these numbers. So if you find the next value for each history in this example and add them up, you got 114. Okay, so that is 68, 28. That's 68, 28, and 18. So what is it? 8, 3, 24, 2, 6, 7, 8, 9. 9 plus 2 is 11. 118. 114. That's right. Okay. So now analyze your OSIS report and extrapolate the next value for each history. What is the sum of these extrapolated values? Okay, let's begin to write this. Okay, so first of all, do we need to parse the inputs? Do we assume this input is a text, is a string or not? Let's get our puzzle input. Let's see how large is it. Okay, easy. So copy that. So create a new file. Okay, okay, and this we'll name it. Let's see how to. Okay, so we have already a name, something like that. So let's go back here. Let's a dem of code 2023 day 8. Okay, so open it. Oh, okay, so wait, today is day 9, right? Yeah, so day 9. So day 9, open it, switch, cut all, close, go back, say, okay, paste it. So here is a puzzle input. Okay, now it's very trivial to parse because it's just a line separated by space. Okay, save it, close it, let's go back. So make a link, show in browser. So we got the advent of code 2023 day 9 input. Okay, but first of all, let's try the toy problem. I mean the toy input. So once you get okay, so input equals to that. Can you see it? Yes. Okay, so we got the input, then string split input split by okay, so there's a question, is each of these, are they always same number of items? We don't know, so we want to know if they are same count of numbers in each line, and also notice they do have negative numbers, so it gets tricky. So how many so let's count how many space 20. Okay, now let's go to this line, how many space 20. Okay, now are all these lines of the same how many space 20? It seems all of them have the 21 numbers, 20 space 21 numbers. Okay, it seems, but we need to verify. Okay, go back to Wolfram code. So string input by new line, then string input by a space. So something like that, we map it. Okay, so in new input. Okay, okay, so let's just try this, run it, let's see what happens. Okay, we got that. That's what we want. Is that correct? Yes. Henrik. Hello, Henrik. Good evening. Hi. I don't know. Would a hash map be a good approach for this problem? I don't know, but I don't think we need to use it. This problem seems trivial, very extremely trivial, easier than the previous days, it seems to me. Okay, so we got this is the input we want. That's fantastic. What's the next thing you need to do? So you just take the difference. Okay, you need to take the difference. So let's put it here so that we can see the output. Okay, so all you have to do is to take the difference. Okay, let me show you guys running it in Wolfram notebook. Okay, let's go back here and let's continue on the problem. So you want to take the difference. Now this is gonna be one single line. Actually, I think I can do it one shot, one single line to solve this problem. So you see, you got each of these lines. You need to take the difference. Oh God! So let's look at how. Oh, okay. So you process each line by itself. So for each line, let's do a toy example. So for example, that's the input. So you're gonna take the difference between the numbers. So what's the best way to do it? Of course, in C, Java, Perl, Python, you do a loop with the index, but We don't do that in functional programming. Okay, so what is the best way to do this? You can, in fact, I think there's a built-in function. Okay, so let's see. So differences. Okay, so there's a function differences. I don't know what that is. Let's look up. Wait. So look up Wolfram documentation. Turn on JavaScript, magnify, gives the successive differences. Okay, that is it. It's so trivial. Run it. You see, that is a function we want. Okay, so the differences returns the differences in a list. You know, this is one of the nature of Wolfram language. Basic, you know, you have 8,000 functions built in. Commonly, you know, any common algorithm, you know, you have it built in, so you don't even have to do code anything. So anyway, so this returns the differences between the elements. Okay, then you need to repeat this until all items are 0. Okay, in other words, you repeat this until you reach a 0, basically. So that's right. So what you can do in this loop, we can just call fixed point. Okay, POINT. Fixed point is a function that takes a function and takes a value. It will repeatedly call function on a value and call the function on a result and repeat, like recursion, until the result is the same. So that's what we need. Okay, so we do this. So this here, you need to be a function, so let's write one. Okay, function, and the input is x, so here is x. So you do that, okay, until, and the input, well, what's the original input? Okay, the first input is that. Okay, that's basically what you need. Let's run it. Okay, it returns empty. Yeah, okay. Okay, so let's do this. You need, it returns empty, that's correct, because then eventually you reach 0, 0, 0, for example. Then the difference between them is 0, 0, and then the difference between them is 0. Then the difference between a list that's just 0 itself is just empty list. I believe that, you know, that's what, for example, we can try fixed point. Actually, you don't need fixed point. For example, let's say 1, 2. For example, we can try that. Actually, we can run this line. You see, 1. So what if you have just 1? What happens? You see, empty list, right? So what if you run empty list? Okay, run it. You see, that's empty list. So you know, that's how that works. Okay, so actually let's comment this out so that other people can see, kind of. Okay, so what we need here is fixed point list. Okay, so remove that. Okay, now run it. So you can see, okay. Oh yeah, okay, I made a syntax error there. Run it. Null. Okay, null is not what we want. Okay, so because you, yeah, okay, let's put it here. Run it. There it is. So here's the output. Let's clean them up so you can see. You see, that is a result. Okay, so you got this. So this is what you want, right? So now you need to take the last number, so 0, 0, 0. You need to take this wait, what does it wants you to do? You take, okay, you start with the line. You start with the line that's right before the or 0. Okay, so you start with this line. You take the last number, then you add it to the previous number. I mean, you add it to the last number of the previous line. And you repeat until there is no previous line. Okay, very easy. So yeah, so I mean the whole problem is just one single short line solution. Okay, so we okay, so what do you do? So let's try. Okay, let's try a different input that has more lines to work with, so we can kind of see how it works out. Okay, so now this one has got more lines to work with. Okay, so this one, you start with this line, the line before the or 0. Okay, so you take 2 plus 6, then plus 15, then plus 45. Let's try. So 45, 15, 6, 2. Add them together, right? Yeah, I think so. So, okay. So what is the result? 68. So 68 for this, indeed. Okay, that's it. So now we know what to do. So this is processing of a line. So you just write a function that takes this line and return this number 68. Okay, so let's proceed to do that. So here you got the fixed point list. Then okay, so you need to start with okay, so what's the difference between fixed point list and other list? Okay, they are the same thing. Okay, so one is just one is just, okay, so one is just fixed point and one is fixed point list. So fixed point will just return the end result. Fixed point list will return each step. Okay, so is that clear? Does that make sense? For example, okay, it's easy to show an example. So f is a function. Okay, you apply a function to a number 3, for example. Actually, that doesn't work because it will stop right away because it doesn't change whenever you run it. Okay, so if you know what I mean, use a new buffer. No, okay, so actually I think I went into infinite recursion. Yeah, we went into an infinite recursion because this never stops. You know, it just f at 3, then f at that, then f at that. It never stops. So fixed point never stops. Fixed point stops only when the result is the same. It's not map and it's not scan. Okay, so map is when your input is a list. The fixed point, the input is just one single value. It doesn't take a list. Well, it can, but it doesn't. It's just single value. It's just okay. So let me show you. So I believe it takes an optional argument to say how many times it recurses. Okay, so yeah, so it can take a step. So let's say 4. Okay, so maximum of 4 times. So you do it. Actually, it's easier if you do it here. Okay, so you run this. So you see, you get that. Okay, you see, fixed point is just a nest. Okay, nesting a function. You start with 3, then f3, then ff3, then fff3. Repeat until the result is the same. So in this case, since our f doesn't do anything, every time you call it, it just nests. So the result will never be the same. It just continue nesting. So fixed point will not stop. But you can add an option 4, so it tells it, a maximum of 4 times. So that's why it stops. Okay. So this is a fixed point list. Now, fixed point is exactly the same as fixed point list, except it only returns just the last element. Okay. For example, if we run that, for example, we run it, it'll paste the result here. No, it doesn't. Okay, so run it. Yeah, okay, so yeah, there it is. Close, run it. There it is. Okay. You see, so these two functions are actually the same. It just this one returns all the intermediate steps. This function, I don't think it's available in other languages. Possibly Haskell, but I don't think they come in this form. Anyway, let's finish the problem. So I've been coding 36 minutes already. Okay, so this does one step. Now you need to start with a non-zero. In fact, you can just take the last element of each line, and you take the last element of each line and you just sum them up. That's right. You don't even have to worry about special cases like that. Okay, so let me try this. Okay, let's see what that returns. So last returns a error. Okay, when the list is empty. So what if we use the part syntax? Okay, so it also returns 0. So you need to treat the special cases differently. Okay, so you can check the length. So what we're gonna do is we map through the whole list. We just take the last element of each until the length, and unless it's empty list. Okay, so let's do it here. So we write the function. Okay, y is the input. Okay, if yy equals to empty list, then return 0. otherwise last yy. Okay, that's a function. Now we just need to map the function to this. Okay, let's do it. So we map this is the function. Okay, and what's the list? The list is gonna be this. Okay, so does that make sense? We don't have prettify here, but anyway, that's it. So now let's clean up a little bit. Let's clean up our let's remove the tutorial things into here. Okay, then delete that. Then we fixed point list. So here, remove that. So what's the difference between these two? It's the same. Okay, so remove that. Okay, remove that. Okay, so let's put some of that here. Okay, so now we got the fixed point, so we pass the input, the fixed point. Okay, so actually we can just run it now. I'm pretty sure it's 68. Oh, you forgot to sum. Okay, now you got that. You see, you need to sum it. So total. Okay, total at. Okay, run it again. Fantastic. Okay, so and now all we have to do is map this into all the lines. So you see so this part process one line. Right, this part process one line. Now you want to make this a function and just map it to all the lines. Okay. Okay, so the code will become complicated, but no worry. Function. Okay, so here function, let's say the input is line. Okay, so and what the function do is this thing. That's the body of the function. And but what is the line? Well, the line is here. Okay, so the line goes here. So this is now a function, and all we have to do is apply this function to, for example, that a line. Let's run it. 68. Beautiful. Now all we have to do is to map this function to the input. Okay, so now you write map. Okay, map a function to a list. We don't care about the level. The list is going, the function is going to be that. Okay, the function, that's the function. And what's the list? The list is the new input. Let's say input 2. Okay, there it is. Okay, clean it a little bit so we don't need that anymore. We don't need that anymore. Run it. Oh, okay, no, wait. Okay, something is wrong. Something is wrong. Oh, the input. Wait, did we get the input? Okay, something is wrong. Let's now, so here is a function, here is the function, right? That's a function and map it to input 2. So why is it wrong? Hello smart man, hello Steely. Almost done, okay? But some problem. So what is the problem? What is the problems? Why is it? Okay, what? Let's see, what does this return? So the input is correct. Something wrong with our function then. Something. I thought we just tried it out and it worked. So there is a function, and let's take the let's take this line. So what? So this is a function, okay, and the function map it to this line. No, okay, you can't have that. So 68, okay, so it works for this line. So is it possible maybe if there's what about that? Okay, error 18. So that was also correct for the first line. And what about this line? It shouldn't be wrong. 28, 68, 28, and 18. You know, they all end in 8. Interesting. Maybe there's a trick there. Okay, so but it works for all the lines, but why is it when you map you got the funky thing? You see, this is the same thing. So it all works, but when you map it, because because this you didn't comment it out. So Wolfram language is trying to multiply that with that. Okay, so let's comment out. Yeah, correct. Yeah, and also this part you don't need anymore. Let's put it to the tutorial here. Okay. Something like that. Okay, so now let's run it. Is it a syntax issue? Where does the multiplication come from? Oh, okay, maybe you need a semicolon there. Try again. Where does the let's see the pattern. 6, 15, 20, 15, 6. Okay, 45, 30, 21. So there you have 45, 30, 21. Now what about 6, 15, 20? Where that came from? Something, okay, something is wrong. So you map. Yeah, let's put the syntax here. Maybe I don't know. So let's copy all. New, paste, magnify, select all, run it. It gives you the same thing. Don't understand. Input 2. And what's odd is that it doesn't, you see, all these arithmetics, they don't actually evaluate for some reason. Oh, because they are strings. That's why. Because the input 2 are strings. Shit. Yeah, the input 2, you know, the reason is because the input 2, let's say take the first element, okay? That's actually a string. Postfix notation. Okay, run it. So it's a string. So you need to convert string to number, okay? So here we just need to string split, okay, and to expression, okay. Let's see. 3344. Okay, let's see if does that work. Okay, let's do that. Okay, that works. So you just need to put this whole thing into here. Okay, run it. Fantastic, that's correct. Now all you have to do is total them together. So you can do a total there. That's the prefix notation, the @ sign. So the answer is 114. That is correct, 114, okay? Now let's try our, that's correct. Okay, we got the solution. Now we need to try the, let's put it back, syntax correct, show in browser. So that is today's code. That's today's solution, basically this line. And now we need to try our code. So, this input text, okay, so let's see. Okay, copy the file path. Now make a backup, pop this out. Now let's read input. So read. Now is it read line? So check. Read line file reads a line of text. No, I want read lines. Okay. So read string. Okay, yeah, read string. So read string of this file, then that is the input. Okay, so the input is gonna be, okay, then we convert it. That's right. So let's try it, and that will be our answer. Do it. No. So we got a problem. Well, that's because of that. Do it again. That's the number. Are you sure? Yes, I'm sure with my eyes closed. So here's a solution. Here's the answer. Answer. There. Submit. That's the right answer. Thank you guys for watching. Okay. Any questions? We're gonna close in 5 minutes. So now let's clean up and maybe clarify for users. So I mean, so you know, this is how you. So you got a bunch of input, which is a list of lines. Each line is a bunch of numbers. Then you parse it so that you turn this number, parse input string, turn them into a list of numbers. Okay, that's this part, and that's what you get. Then what you do is then it's just this. Okay, we explain how that works. Okay, so for now, this part, let's remove it and let's put it back to the explanation code here somewhere. Yeah, so that will show, for example, you can call the differences function and that will return that. Okay, and you know, so, and this will return. So this is the explanation part. That, and the special case, a difference of just one single number, what you get is that. Okay, and same thing for that. Okay, so you apply. So now we apply differences recursively. That's this part. You apply the differences recursively, and the result is like that. Okay, so yeah, so we don't, so, and here is example of what fixed point do. Okay, so this is kind of the tutorial part. Put it back, syntax correct, show in browser. And now the real code part is just this. Okay, so yeah, so this is a sample output and here's a solution. Okay, good. Let's say solution. Okay, so this is part 1, Advent of Code 2023 part 1. Okay, now put it back. Wait, what? wait, what is this? Yeah, for some reason I fucked up. Oh yeah, because Talk Show pre. Yeah, so this part is fucked. Yeah, now you can put it back. Now cut that part, tutorial part to here, then syntax color the whole thing, show in browser. So this is a solution. Oh, let's magnify. So now you can see. And now let's shorten the solution. Okay, so now let's shorten it because it can be made much shorter. Okay, let's just use that default input. Okay, we don't need that. And let's shorten this line. So how do you shorten this line? So you can just wait, let's try it again. Oh, there are 2 lines. Okay, so gonna try it again, put it here. So that, okay, then you don't need that. Okay, so and the function x, okay, function x, you don't need that. So the function x is actually you don't even need that. So just that, and the map, you don't need map. So there it is. So you map this function to this expression. Okay, you don't need that, and the whole thing to expression. Okay, so this line is equivalent to this line 100% syntactically. You know this, so this is using Wolfram shortcut syntax, and in Lisp it's called meta expression, but Lisp never went far for that. So this line is so the Wolfram language will, whenever it start to evaluate the code, it will first turn any shortcut notation to this fully nested notation. Okay, so that is why they are 100% equivalent. Okay, so in fact, since we are doing the short version, we remove all the comments. Okay, and here is very similar. Okay, so we can okay, so let me clean up this code so to make them extremely short. So yeah, this is so redundant. Okay, so fixed point, yes, we need that fixed point list. Okay, then okay, so then here is a function. Yeah, function, you can just okay, so it's just that. Okay, the function, so here, so these 2 lines are exactly identical. Okay, so you don't need that. And map, again, map can be written by like that. Okay, so map this function to this thing. Okay, so you don't need this map, and then total it, yes, and then the whole thing is a function. Again, we change that to, so the whole thing is a function. Okay, so grab, okay, well, so you that okay, so it becomes less, it's become harder to understand if you don't know Wolfram language, but we can write it this way. That's right. So that's right, and you don't need this. So you need to map it to input 2. That's right. So in fact, the whole thing is a function. We got so many nested function now. It's another one. Okay, so you need to wait. Yeah, so that is a function. Wait, I lost track of. Wait, we. Okay, we don't need this. So here is this is a function. We map this function to oh god. That, okay, remove that. So now this is a function. Okay, now you just map this function to input 2. Okay, so you don't need that, and then you just total it. Okay, that's it. Run it. Okay, that's it. Let's try it here. Run it. 114, that's correct. Bye guys. If you like my stuff, donate, okay? Do you have any thoughts on Go? What Go? You mean the Go board game? Yeah, I had lots of thoughts on Go. So wait, let's put. Are you talking about the Go language or the Go game? And where can you find the Emacs theme? Okay, so let me tell you. But here is the today's talk show on the advent of code. So the solution is just this single line, and in fact we can make it even shorter. Yeah, we can. But you know, but that's that. Okay, if you want to know my Emacs theme, just go to XR Emacs, search XR theme. Okay, there's no XR theme, just search for theme. Set color theme. theme gallery. So how to create your own theme, how to set color theme, and theme gallery. So you can see there it is, my theme, XR-gnome theme. Create the following file, save it as XR-gnome theme.el, and you'll have my theme. But my theme is basically no theme. It's just background color, that's all. So I don't use this. All I do is just this, okay? Set, let me show you my init, okay? So init, not that, init. So Emacs init, go to the top. Oh, okay, so go to the settings, go to the top, background color. There it is. That's all I do. Just background color, honey Drew. No theme, no nothing. But if you really want to do the same thing with a theme, then you create this file. But it's problematic because when you move around computers, you need to have this extra file. If this file does not exist and you set the XR theme, Emacs will error out. So it's much easier if you just set background color. And yeah, so here is all the themes, theme gallery, theme tutorial you can read. And Avisk Crystal, I think. Thank you. Will you ever use the Acme editor? No, I don't think so, because that's on Plan 9. Is there a version for Windows? Maybe there is, but I'm not likely to use it because I'm getting old. I don't have time to play with all the different things. Okay, it's on Windows and Mac OS. Yeah, but I got mathematics to learn, functional programming, proof theory, type theory. There's lots of things to study than than playing with editor. If you are young, that's fun. You can explore, and get experience about editors. But for me, I'm too old for that. Okay, bye guys. That's it. We shut down in 1 minute. Yeah, okay, we already. Okay, so close that, close that, close that, close that, close that. Beautiful. That's it.